Okay, so welcome everybody back to our class on mechanics materials. This is session 2. Yeah. So as yeah. Okay, so there's a little bit of commotion, but what we're going to do, so we have one group over here, all right, so you two plus Kayla, and the Ethan, Tyler, Thomas group back here, and then we'll have you four as a group, okay? So, good. And then we're missing another one. So, yeah, welcome back, and here we have an opportunity to review some material from statics. Okay? And as you go through the video that's available, you'll be having the opportunity to look at a few different types of systems. Okay, so axial loading bars, shafts, and beams. And you'll probably, I mean, if you've taken statics recently, you'll probably be like, okay, yeah, I remember this. And that's right. It's an opportunity to remember some of the things that you've done in the past. At the end, there's also a little bit of treatment on trusses. And there's not a problem right now, okay, for everyone on trusses. Nonetheless, it's good to know that there are two different types of techniques for handling trusses: method of joints and method of sections. And method of sections is what we also use for beams and bars and shafts, quite frankly. Okay, but the method of joints is a little bit different. This is a review section, so I just want to take a couple minutes to point out some aspects that may be at times a little bit, whoops, I don't know what I just did, a little bit confusing, and I think are worth pointing out, all right? So for bars, okay, when you're dealing with bars in static equilibrium, something to keep in mind is that we're first looking at external equilibrium, okay? And then we break it down and we look at the internal system. And when we do that, there is a convention that we typically follow for this method of sections on a bar, okay? And so what you might see like this is a bar, okay? And maybe we have some external force here and some external force here, okay? And you're like, that's really simple. So if I do external equilibrium on this system, right? So external equilibrium would be something that we look at first. And I have to get myself calibrated with these. And you're like, this is really simple. Yeah, it is. It sets the tone, okay? And, you know, in this case, we're really probably concerned in the x direction, okay? Because this is axial loading. And what are we saying? We're saying, well, we could say this is the x direction. So it's pretty straightforward. This is F minus F is equal to 0. Right, and which F? This one would, you know, I'd probably say this is the positive one, right? Because it's in the same direction as the x. This one I would say is the negative one, right? And that's why we have F minus F. When we do method of sections, what we will have is something that looks like this, right? And we have this external force on the left side, and internally, right, we can draw something like this, Fi. That's the internal force. Typically, what we're going to do is we say that the positive direction is coming out of the open face. Okay? So in this case, again, we can do equilibrium, but we're going to do internal equilibrium. Okay? And with this internal equilibrium, we are going to say, okay, there's Fi, but I also have this external force acting on the system. Okay? And that's going to be equal to 0. Now, what often gets confusing is if you take a slice from the other direction, right? So now I'm exposing the left side, and I have, again, an Fi. I have an F externally, right, on the system. And my internal equilibrium, when I do this out, I'll have a negative, okay? Or if I'm using this convention right here, all right? But if I'm using the convention where Fi is positive coming out of the face, so I have kind of a choice, right? I have a little bit of choice. But if I use this convention where I say this is the positive direction, then Fi is still equal to minus F. And that's still equal to 0. Okay? Now, what's confusing, right, is that Fi seems to be going in two different directions in these two different diagrams. Okay? Right? And Fi is equal to F, obviously. Okay, so which is correct? Well, they're both correct. Okay? And this is a classic situation that we'll encounter where we slice from one side and we expose the right side, and we slice from the other side and we expose the left side, and the forces that we have, the internal forces, are the same, okay, but they're looking to be in opposite directions. Okay. Now, what's important here is the sign as well as the direction. So if we had that Fi, okay, so of course we've got that Fi is equal to F in both of these situations. If Fi is greater than 0, what do we call that? Tension or compression? Tension, right? Okay, so that's in tension, and you can visualize this more easily because if I look at what's happening with the external forces, if Fi is positive, the F external is also positive, and that's pulling it apart. Okay, and so what may be a little bit counterintuitive is that Fi, right, with one slice, of course, is going to the right, and another slice is going to the left. But it's coming out of that face, and if it's coming out of that face, that's positive, and it's positive. So if Fi is greater than 0, then we say that the member is in tension. Okay? So that's the bar and static equilibrium. And so you have a chance to look at this in different scenarios with multiple loads, okay, for the problems on a single bar. And of course, if Fi is less than 0, right, then we say that the member is in compression. Okay, so you're like, this is super simple. Super simple. Let's look at shafts quickly. Now, a shaft is really a bar, but we use that term shaft because it's transferring some type of torque, okay? And it could be in rotating at a constant speed, and it could have some power associated with it, okay? But it's a member that is handling torque. So often what happens is we draw something that looks kind of like this, or at least I do. Okay. And there's more of this, of course, in the notes. And the convention that we often use, okay, is following the right-hand rule. Okay. So if in this case we say that this is a positive z direction, let's just say it's positive z, and I apply an external torque, okay, T, then that would be following the right-hand rule, right, coming out of that open face. And this is external, okay? So we're doing external equilibrium again at this point. Now, this torque I'm going to put in the opposite direction, okay? And I'm say it's the same torque, okay, so that this thing balances out. Now, what I could have done, though, is drawn it the other direction, right? And then I might have called it something else, and it would have had a negative sign, okay? But for external equilibrium, again, what we have here is this is the positive one, okay? And this is actually acting in a negative direction. I'll just do it like that, okay? And so T is kind of giving us a magnitude here. And so when we do the sum of the torques, okay, and we can say it's in the z direction, and that is equal to 0, we would have something like T minus T is equal to 0. You know, like this is boring. Okay? Now, when we do the internal equilibrium, like you see here, again, we keep this external torque here that we already drew, okay? And now, once again, we have an opportunity to draw an open face, or draw a torque on an open face. So in this scenario, maybe what I should do, right, is say this is the positive direction. And so if it's positive, okay, coming out of there, right, it's got to be going in this direction. And now my convention, all right, I've said that I'm calling that purple plus, right? That's the positive. So when I do my external or internal equilibrium, okay, then I have a positive Ti. But now the T that I had originally, that I was calling positive over here, right, this one and this one, that's in the negative direction, okay, with the reference frame that I've picked, that we've selected, okay, and that's going to be equal to 0. Okay. So I know that Ti is equal to T, that's fine, okay, and in the notes what you'll see is, you know, I draw some grids and we talk a little bit about, okay, which direction is this torque twisting the shaft, okay, and that can be helpful when you draw a grid on it and you think, oh, okay, this side's going this way, this side's going this way, to kind of, because what we're going to eventually do very soon is map that to shear stress. Okay. So another thing to point out, of course, though, is just like the bars, okay, if I were to take the cut the other side, right, and I were to do right, the cut on that face, right, again, I can do an internal TI. Oops. Right, and if I call this the positive direction, which direction am I going to map TI? That way, right, so that it's coming out and I'm following the right-hand rule. And I had my other torque externally, right, over here, which originally I said was in the negative direction, right? That is still in that direction, and that's going to be negative according to this reference frame as well, okay? But what we're trying to point out here is that TI in this case and in this case, even though they're in opposite directions, when they're describing this internal torque, okay, they are the same. Okay, so it matters which side you're looking at, okay, for this thing. And so another way to kind of look at this is to say, oh, I'm going to be balancing internal torques as well. So I could also draw something like this, where I have a fuzzy side on this side, and I have a fuzzy side on this side, right? And now I've got kind of two internal slices, all right? And I'm following my, and now I kind of got to pick, right? Or it's kind of weird because I got this, okay? And so maybe I got to pick that, right? But then I've got to have some balance, right? So I could also say, well, I've got this here, right? And these are both positive in their own reference frames, right? And these are balancing each other out, okay? Even though they're in opposite directions, okay? They are essentially the same. And this goes to our analogy with internal equilibrium for bars as well, right? I can go back here and I can say, I'm going to do a fuzzy one over here, and I'm going to do a fuzzy one over here, okay? And these forces are, seemingly acting in opposite directions, but they're the same, right? If I took another slice here, right, depending on which side I'm on, I'm going to have an internal force, and they're going to be in opposite directions. Okay, so this is often confusing. And then when we look at bars, okay, if we look at bars, I'm sorry, not bars, look at beams, okay, we have a convention that we follow, as you will remember and as you recall, right? And that convention is something like the following. We always have a smiley face, so the moment, right, this is an internal moment, that way, okay? But then we also have internal shear force, okay? We'll call it like that. And that's down. If we cut the other direction, okay, we will have the internal shear force going up, and we'll have, again, a smiley internal moment. Okay. And so this would be a reminder from your days of statics. All right. And again, if this is one beam, I can choose where I'm going to cut, but the MI, even though they're in opposite directions, right? MI, right, and VI, they're in opposite directions depending on the face I'm cutting or exposing, right? They are equivalent. Crandall, Dahl, and Lardner, so we're using the convention from Hibbeler, all right? And if you see on the webpage, I've added the complementary section in 3 versions of Hibbeler's book, the 11th, the 9th, and the 8th editions. All right, and it's all section 1.2. Okay, equilibrium of a deformable body. If you go into Crandall Don Lardner's book, okay, what you'll find is they actually use a different convention for the moments. And that was confusing to me because that's the book I used when I, what I would say is when I was first teaching this class, it's like, why is this backwards? It was backwards because CDL, Crandall Don Lardner, used the opposite convention for the internal moment. Okay, one is not necessarily better than the other. Okay, and if you look at the Wikipedia links that you'll see throughout the class, they sometimes use a different convention from Hibbler as well. Okay, all right, so we'll go ahead and let you get going on the video and on the homeworks. Of course, session 1 was due yesterday. Due this morning at 10:30, and we've also set up groups for the work. Okay, so we've got, and if there's an issue with these groups, just let me know, and we'll change it up. All right, but we've got, for now, we've got this group of 4: the Julio, Carlos, Owen, and Mark. All right, so you 4. For now, we've got Ethan and Tyler. If you want to go over there, we've got the Ethan, Tyler, Thomas group. All right. And then we've got the George, Ibrahim, and Jason group over here. Okay. So if you guys, I don't know if you can just work. So as you're going through the videos, you can be on your whatever you want to do. But the goal is to be able to have people to work with on the problems. And then, yes, Kayla's not here, but I was anticipating that you all would be in others. And I guess if you want to join them, right? Yeah. And I believe your name is Karen, right? We share the same name. Okay. So yeah, you can join them. Yeah, so if you go up all the way to the top. Yep, helps. So no. So I rearranged it for you. I rearranged something. Okay. Yes.
I divided the function with the
Sure. I'm not going to quote you here. Okay.
I just divided and the function.
So like I could take attendance.
Yeah.
Your year. This is great. Wonderful. Okay. And then how you want it. I'm not going to keep you here. Right. You can always go to the next one too. Yeah. Right. So there's always more and whatever. And so I will, Aaron, I'll add you to this group. Yeah. It's in Canvas, yeah, but I didn't have you in. Yeah, I got it right.
Why did I mess up?
Yeah.
I think I have one like that. That's literally why. I think one like that player. I got to do it wrong.
But I'm not saying maybe like that.
But you got that one.
Yeah, we did these. Let me check. It's like
Was the original 10,000? Yeah, that was the same. Also,
it's like they put it wrong.
did it say Newton or it's not? Because I know that it's weird. That's what you do the conversion.
No, yeah, I didn't. I didn't.
Okay, so attendance.
That's 160 is converted. I literally just did it and just converted the final answer. Yeah.
Wait.
Yeah, man, it's just.
Oh, yeah, divided.
Yeah, I'm back.
I was in the other.
So,
It was Matt, right?
Correct.
Okay. Julio, right? Okay.
Oh wait, no. Just here. If you cut it here, you have to have a between the force. Here, that be the force between two and the basically forces. So you have it between here and the rest of the side. Or you can, but you have to do B, C, and C. Should they all be the same?
Yes.
So, for this one,
Yeah.
would you have to like here, and the internal forces between B, C, and G as like external forces?
Alright, so that could be one way to do it. I think the most straightforward way to do it is to take one. So in this case, we're looking for the force BC, right? So that's between B and C. So here, take a slice, and then you can have a choice. You can either use the slice and open to the space on the right, or you can open to the space on the left.
Yo también pensé
Right?
que
Then what you're doing is you're using the
si no iba a sumar y
external
pasar
forces
nada.
and that one internal force to figure out, okay,
Estaba a punto de decirle que yo voy
You can just
Cada uno
use
tiene
those
sus
forces, just basically make base open force with those, right?
right, so yes, so you have, the easiest way to do it, I think, is to say, okay, if I slice here, I have,
porque yo
you
hice
know,
recuerdo que
usually open space, right?
puse todo bonito.
Yeah,
y
mine
era una
But
puta así.
then that open space in my positive direction, and that's where I'm gonna call my FEC. And then what is FA and what is FE?
Oh, we look
In-
And then his example is FB plus slides, right?
Yes, so FA though, right, this, I'm opening and I'm opening to the right.
Yeah.
Okay, FA is negative, FA is positive, and FEC is also positive.
Yeah.
Alright?
Oh,
You got it?
I have curiosity to understand, like,
Yeah.
the way I said, I know it's what it would it work, would it actually?
Yeah, you have to figure out, so if you can take a slice here and a slice here, right? But you need to figure out what internal force is, right? So you're gonna have an FAB coming out of that face. And so to figure out FAB, you gotta look at what, so FAB would just equal to FA, right? Because that's, again, you're looking at what is the external force and how it's connected to
Pensé que
external.
tenía un-
Does that make sense?
No, entonces,
Okay, so, let me see, which group?
¿qué está hablando conmigo, bro?
Fuck.
Oh, so just add my.
And it's always in the very first.
Sí, mucha gente tiene 6. Un poquito. Toditos, no necesitas leer nada. Toditos al final es pura esta. Sí. Excepto esa. La siguiente, digo. No, esa. Hay otra que está medio rara. Creo que era la 6 o la 5. Estás pasando de ver. Quieren que lean sus ojos.
Okay, so Aaron, I've added you to group 4. So just so you know, on Canvas, with the groups, okay, you can also like create your own messaging inside the group if you like.
Check it.
Okay, you're not forced to do that, but it's like an extra tool if you want. Okay. And you might, want to exchange. The class is small enough that you could just use the group meet, to be honest. But if you want to internally communicate with each other,
That's right there.
Oh, I think it was on the
Okay.
title.
I put it right there, and these two up, that's that.
Yeah.
And these two up close to that.
Okay.
Pick one. And then the other side was the race, so.
It's 19.
Maybe it's just good.
and I guess what I found, I want to let you guys think, but what I found is that early on in the course, a lot of people skip the videos. But as we get later on in the course and things get more complicated, okay? So either, no. So I'm not saying you should. I'm just saying that is, I think it's better, to be honest, I like the videos because I made them, right? So it's up to you. But I'm just saying that it will get to the point where I think you will want to watch them more, okay? But it's good. So do whatever you want.
Ahí simplemente por equilibrio, pusiste abajo y pusiste para arriba. Se lo alrededor. Y yo así, entonces se gira para el otro lado. ¿Qué te pasó? Más modificamos en pause. Yo dije no mames, multiplícalo por ¿qué? Entonces en el tienes que dividir por 1.36. Está en las notas. 1.36 por la columna.
Question two, let's just do, moment, just do it. I kind of know. Every color is supposed to go to. Well, and the change units also in the grid river. Which is just the 5 by
Matt, had you? Pound for? Yeah. Has, well, I gotta eat.
¿Qué es eso? Está en las notas la conversión total. Es un bit igual a 1.36 Bueno, al revés. Es que esto es 1.36. Pero ese es, no, esto es NM, no es Luna. That's stored.
Just so you know, we are recording these. So here. Okay. Para que sepa. Just so you know.
We should do the same thing, we just see what these are.
well, the community comes back.
Is the negative important
So, where? Which one?
for
Okay. So you're talking about this, right? Okay.
So
So
let's see.
this equation right here is just to show external equilibrium.
There's
Yeah.
Okay. So when you're doing the internal equilibrium,
You
Alright,
make the cut side positive.
you make the cut side positive, so this, when you do that, this will be ending up in a minus method, so it will be a minus method, right? If I were to take a cut here and I were to expose, the right to space.
So our answer could be positive.
Well, no, I'm not saying that. I'm not saying that. That I did not say. I'm just saying, yes, these signs are important.
Okay, so the convention here is positive. Because we cut on this side, you have to split the convention, but we have the answer, you have the convention next to the positive.
So you actually don't. That's the interesting point. Okay. So this is this is the reference frame that we're using for external equilibrium. But when you start doing the internal cuts, your internal reference frame can change. Okay, and so it's advisable to be very careful there, right? All right, and remember, depending on which way I cut, right, I have an internal force going either direction, and so it is the same internal force.
Yeah, so,
Right.
any movement is,
I see those points here, so that's why.
Good. I'm glad you're asking these
so
questions.
what's next here?
Thank you, Mike.
What's-
Do you all have any questions? Are you listening to the video? Or are you just working? You did. Oh, so you're doing. Okay.
Trial and
All
error.
right, so we're on session 3. All right. That's that is fine.
Again, what do you think?
Yes.
So I have
Oh,
a question.
yes.
So for this one,
Yes.
moment, it's
I
true
wanna guess it's supposed to be like
that it doesn't show
One
like
of you point to that spot.
Ah,
Wow, so
okay.
do I like
I
guess?
do what it is.
I guess it's, yeah.
Okay.
So it's gonna be point data.
All right.
That's right.
So there's a question. I think that if I could have your attention just for a minute, there's a nice question that Owen brought up here. Okay, what happens? What's the convention for external forces? Is there a convention for external forces? Okay, and external moments. And the answer is no. Okay, you can do whatever you want. If it's an external force, you can draw it left, right. It's that has significant consequences on what's happening internally. Okay, but it doesn't really matter. So in one case, the case you were looking at, right, or something similar to it at least, is when you have a let's just say that this is a cantilevered beam, right, with some length L, and there's a force P being applied. If you are looking at the external force and the moment from the wall, you have choices. You could do it either way, it's fine, okay? But what I try to do is I try to guess which way is going to be positive, okay? So it's fine to take this, okay, and say it's going to be like this, okay? It's also fine to say it's going to be like this, where I have P down. Actually, I'm gonna do R. I'm just gonna do R there, okay? Because that's not internal. Okay. So I could do either one, but when I solve MR in these cases, it's opposite. There's going to be a negative, right? These are opposite. Okay, maybe I should have picked different variables, but those are opposite. Those are going to be negative of the first case. Because you can keep it, you can make them positive. I often like MR, right? That's that MR on this one, right? This would be my preference. Okay, because I know that R and that MR are going to be positive to counteract the P. Okay, when I do the right, because if I do external equilibrium, which is what you do first before you do internal, right? I've got some of the forces in the y direction equal to 0, so that means that I have R minus P is equal to 0. So that means that R is equal to P. And then I got M, and I gotta pick a location, so I'm gonna do that O. All right. If I do it there, then I've got and I'm saying that Z is I'll call this Z coming out.
Oh, no, it's
All right.
P times-
So that P
P
times L. Okay. So I have this has got to be equal to 0, right? So I've got a minus PL, okay, plus MR,
Not really, but there's-
okay, is equal to 0. So that MR is equal to PL.
Okay.
Do you see? But if I do the other one, if I do the opposite, the one below it, my MR will be negative of what I have there. I'll have a minus PL, and I'll have a minus
Oh, yeah, wait, hold on.
R, or a minus P for R.
Oh, here, can I be the-
Okay, if I do this one, this one would give me MR equal to minus PL, and R equal to minus P. Okay, so that's, you have, so with external torques, or external, well, torques too, but external moments and external forces, you get to choose, but usually you guess appropriately. Okay. When you take the internal cuts, that's when you got to keep the convention in mind, right? So anytime you see a squiggly line or squiggly curve, that's when you want to keep the convention in mind. Good. All right, keep going, guys. Keep going. You're doing great.
Wait, what addition is it?
Just addition doesn't matter so much. I think so. I mean, it's a. Taking up letters now?
I'm sorry, I'm taking, Calc 4.
Yes. Right, oh, there. So it's not. It's this one?
No, it's in the R corners.
Yeah, one second, right? Yeah. Here we go. Yeah, that's service. As a listing general, it'll work, yeah.
Professor?
questions, is there anything we could do to get added or something?
If you've done this, you can go on to session 3.
Oh, really?
Wow, they're all available.
Do we have one other?
That's all. I mean, if you got a good grasp on the different aspects that you live in, then yeah, that's good.
Era líquido, un poco diferente. Pero tiene medio disposable, una X creo.
Yes. Yeah. Touch.
I haven't heard anything yet, but isn't it supposed to be two? Even this is present.
Well, right now, this is K delta, right?
Negative, right?
Well, is it? Depends on what we're talking about.
Well, I'm trying to actually negative one.
So, so it's in microns. Mm-hmm.
This is not.
That's not microns.
It's not.
Nope.
Yeah, because it's not coming. Millimeters. Oh no. Oh. So different. Resets. Okay.
Oh, micrometers. Micrometers. That sets me down there. It's 10 more.
I'm just
like,
oh, yeah, yeah, okay.
No, wait.
Okay, good.
Yeah.
Okay, so I get the answer. So times, it times 1,000. Right?
Well, yeah, sure.
Yeah. So
Yes.
times, oh, I was sorry, what?
Yes.
It's K, so it's 4, so K.
At least it works.
Two kilograms. 2 around 15. So it's in kilograms. Okay.
Well, you don't need to
So-
compare it to.
Yeah,
I
so
know,
you
I guess
can
what I
definitely
did-
use the right hand
Well,
rule.
you compare it
And
to.
the question is, which direction is positive and which direction is negative? So like, that's like one of my wishes. So
Really only two
the
questions.
thing to keep in mind is that when you take your thermal
Why the
slice
separate window?
And the positive returns.
out of the face.
Yeah.
Like,
So
I mean, modules
if
are.
I take a slice between B and C, if you go in the opposite direction, that's what it's.
Wait, why does session three?
And I want you to take
Well, slow down.
this slice. We can just say that let's
Maybe
use
it's
the
the
BC.
Separate,
is
I only found this one separate.
So yes, it
Wait,
will be,
just-
that's
do the same
how I
data,
would
so
define
just
it.
cover
That
that.
would be my right hand rule for the
That's so weird.
direction
Find me.
out of that face.
So then I want to make that slice that that the central part is going to be.
No, so they,
It's
I was
gonna
added
be
and
define it, yes, as
I got a
positive
million.
based on that face.
I like last tax, it's
So
like
if-
classify
I'm
slices.
gonna take a slice here, right? And
It says physics too, but it's.
I have two
You already
options,
take-
right?
you already take-
First of all, you have all those
So like
notifications
that
on
can't
upper
cause
hand.
the cover.
Which is
Okay, so I either cover up the left side.
It gives
or
me
cover
three
the right
notifications
side.
for like my Samsung.
That's what I'm doing. It's
So
even
if I
when
cover
you
the right side, right, then I've got one.
Debe ser igual que
It's
el
kind of
de
like
direction.
notification.
Yeah. It's like.
In general, I can ask that. It's sort of.
But if I cover up the left side, then I've
You'll
got
flip it first
two
one.
positive directions in the same
Or
direction
email.
that
Like
C.
Yeah.
And so I would draw the same direction as this here.
Yeah.
Okay, does that make sense?
Yes,
Thank you for, yeah, thanks for asking. Yeah. It's really good to get the convention down now, because it's just,
It gives me three.
it keeps going. So like, I remember when I was teaching like mechanics, like, not like physics, right? And I was like, they're like equal and opposite reactions, right? And I was like, oh, I'll just like push two forces in opposite directions on the same object. And like, no, that's not actually happening there.
Equations, I'm really that. Maybe. Okay, come on, so. If there, do this right. If there's a displacement, if there is a displacement for but then obviously it can't be, so that means that there's no after reaction goes out. To make it something like that. Oh, actually, I can see this. Okay, let me see. This is steep.
Why did that?
Do you remember her? She was super.
I was the real person. I was the real person. I was just like, moving on a pilot.
So can you realize this past year, right?
High school. No, you know, like college, I did a real way.
Well, you got your pretty well that you see in say 19.
I think I was self-aware that I was not real.
I was a pretty
Right.
person. That's a good thing. You draw your that you draw. I think I'm kind of cool. See, we start
Yes.
Okay, so I'm gonna figure it out. So the displacement here is taken on numbers. So my numbers. So this displacement in reality has to be 10.5 meters, so that's the reacting force. Is trying to counteract some of this displacement. No.
The displacements have to be the same. So I would go through the notes and use an equivalent spring system.
You do that.
That's the whole, that's kind of the point.
Oh.
Okay?
I use your notes.
Yeah. So there are two ways to do this. Okay, but the simpler way, okay, is to do this as
Springs and curls.
spins. So we have spring here, spring here, okay? But you have series that think about them being this actually gives me rather long. That's hero series. Okay, but it's or you can use compatibilities, right? This two things displacements happen. They're like at the end here.
So I don't hear something like springs and series use like you do for narrow.
Yeah, but it's this system does not. So it looks like it's in series. But
So I plugged it into,
oh, and we'll talk about this.
Is that kind of versus?
So we'll talk about this next time. Okay, so George is now here.
Yeah. I followed them all. You just pulled them.
Okay. Alright. I guess this step down.
Yeah, it is.
Okay, I'll go to mark in this here. Hey, how you doing?
my phone updated yesterday, so they're like.
Okay.
That's it.
I'm gonna put this here. Thank you for coming. Your phone updated?
Yeah, I got a degree yesterday,
Oh, okay.
so it's like still going through the process.
Okay, alright, well, we're glad that you're here.
That's just, I'm like.
You can also,
I was doing I wasn't even reading the question.
you do the messages, the video units, that's on this. We have a recording.
It's on session 2.
Yeah, we're on session 2, that's right.
And then it was
So it says.
No, it's just, it's like resistance.
So it's like a spring. Like, think about it, this is the spring.
Well, that's why they're like in parallel. Instead of
The springs that are like compression or something. There's the springs in there, like. Pulling springs. There's pulling springs on both ends. We're just pushing spring into itself on this side. So are we treating this as if it's like on the target? Isn't the same food? Or maybe it's really like opposite is that?
maybe it's I'm thinking about it, it's just so it's slow. Just like it would.
No. You don't worry about that at all.
Yeah.
I'm just gonna wait. I'll have to go to Home Depot.
Have a good one.
So what are you going to Home Depot for? Building a guide table. Oh, okay.
We'll see you tomorrow. We have class tomorrow.
Did you see that?
Oh, I said that. I should say. I think it's testing this.
I have a question.
Yes.
What's up? So for this one, question 3. I got it right. I'm just trying to think intuitively. Initially, I just mixed it.
sorry.
Yeah, so it makes sense to try another way. But thinking about it, right? I cut it here, and that's FSD or FCD, correct? But I did plus FA minus FB minus FC equals FCD. Okay.
Yeah.
And I'm trying to think why that would make sense.
Yeah, so why don't we want to draw it out?
Draw it out.
And so are you exposing the left side? Yeah, right
Cut
there.
it there. That's FCD.
Can I send you my message?
See what's that for something like that?
Sure.
See what's that also? See what's that?
Correct.
See what's that?
Okay, so
And
this
so
way,
yeah.
I want medium just
It's also.
Correct. Yeah.
Pick one, Thomas.
so this.
I would say I wouldn't even do it like that.
Just tell me to pick one.
Besides me.
I say, okay, you can start with FCD. So
I'm not-
FCD plus
Fine, so what's that for?
what's going in the same direction as FCD.
B and C.
So FB plus FC.
Oh, yeah, that's.
And then minus FA.
Oh, okay, so that's exactly what I was.
Yeah, so this is just to give you the minus FA equals 0.
No.
There, now.
Yeah.
Yeah, no, I think it's important to get it straight, okay, because, yes, this is all addition and subtraction, but you just get the right answer, and like, you're not following the conventions, yeah, then I get it.
Así que mientras resuelvo estoy dejando de puntos a
For the future,
no tiene que
for
ser
the
un
future.
de uno.
Good. Thanks for asking, Owen.
No sabía que existía. Serious springs. Es como circuitos. Sí, no sabía que existía. No sé si lo vamos a usar ahora, pero lo voy a anotar porque dijeron
And then no class tomorrow.
No classes on Monday, so, yeah.
Thank you.
Okay, see you, have a good one.
¿Fuiste tú? ¿Fuiste tú?
No, en la casa.
That is what 46. And the internal force has to be that has to be this force right here. If I get start, yeah. If you do it at both, It's called the external controls, but the internal controls. Maybe it's it's always positive. Oh, we're gonna give you Oh, it's over.
Yes, Mark, what's up?
This is the reaction force from the wall acting on the bar's one to the left. Doesn't mean like the force of the bar on the wall is like to the left.
So that's the reactive force on the bar, which is inside. It's because look through the force point, that's where there's gotta be a reaction force from the wall is pulling in this direction.
Right.
I just see the big,
We'll go through some of this tomorrow.
I know.
This guy is really good, the efficient engineer, his videos are really good.
Yeah, like it.
Yeah, so it does a nice job explaining the concepts. There's some really, I mean, I can't, it's like, how do you create these videos, man? It's like, there's all this graphics and everything. It does, yeah. Yeah, so throughout the course, we'll have his videos. It's very relevant.
Recuerdo que ayer no pude darme de un cuanto. Yo tiré al azar hasta que me salió. No, nada. Session 2. Porque la gente me pasa. A tu en casa.
Good stuff. You know what's going on, huh?
Yeah,
Alright.
so far it's just statics, but that's how every class starts out.
We'll be getting to some new stuff soon. Good.
Thank you, Professor.
Good. Yeah, it's important to get these fundamentals down. It really is.
Beautiful.
See it.
Professor,
Piso, hermanos.
Yes.
Tengo que ir acá a que me firmen.
I just want to like clarify something. So when we're trying to find like the superposition of this, we have to relate the distances
No sé.
together.
No
Right?
sé.
Because the distance, this being like since the beam is like between two walls, right?
Right.
So then it's under like those,
Yes.
under walls.
Yes.
So then beams have like this four blocks to it.
That's right.
So then I'm thinking like, are the distances like this? Like, it doesn't change distance, right?
So, yes, so we know that there are different ways to look at this, right? Right, so if you go, this is, I mean, we'll go through this tomorrow, right? But if you have this wall here, right, that means that it's constraining it, right? If I take that wall away,
Move.
this then moves to the
Yeah.
right. Okay, so that displacement is interesting, it's important, right? Because then I can apply some historian force here that goes through this whole system
Voy a ir a que me firmen. Voy a ir a que me firmen.
to get the same displacement in the opposite
Para
direction.
hacer. Era eso o irme al banco.
Yeah.
To zero.
Oh,
Voy a irme a dejar ahí.
So then
So
the
all
restraining
you
force
want
would be like this.
so the restoring force is going to get right at FR.
Yeah.
Yeah, and this is like springs in series. That's what I'm
Yeah.
right? So
No sé, algo así.
I'm applying an FR, and if it's a spring in series,
Fíjate,
the
¿no?
force now
Sí,
is
sí.
that FR is the same inside this member as it is up here, because they're in series with each other. Right? Or you can think of this as I'm not, now I can create an effective constant for this whole beam, right, that is experiencing an FR, and I want to know what the displacement is, right, so the effective spring constant here, right, is going to be K1, K2, or K plus K2, everything,
Como
or 1 over.
sí, ya. Pesa un poco.
So there are multiple ways. There are multiple ways to hack a problem. I'll also say another way to do this
this is actually these two springs are parallel. What the springs are resisting the force applying, right? So they're working together to resist that applying force. So you can kind of like swing this around to the side and think of it as a force now being applied to two springs over here. So the simplest answer, if you're looking at displacement in the middle, is just add these two springs.
Fui corriendo con la bici. No sé bien.
So there's like a whole bunch of different ways to do that. But if you're looking at the force, right, then
Doesn't make sense, right?
yeah.
Yeah, I was just wondering how displacement. Yes.
Yeah.
I
Does that make sense?
Yeah.
Okay, thanks for asking.
I should be fine, it's just taking a long. We can just focus on this, so I can't take it and watch.
It's okay. There's no rush. It's good. It's important to get this session down because we're building. We're building.
And I'm in.
Can I get your stuff?
I gotta read my stat, bro.
Later, no.
I don't use that much of it.
I was gonna say, I don't really use it.
Actually, one of the numbers we just do group chat, right? Okay, so I have to work from here, maybe.
This might be easier, just type your number in.
Yeah, there you go.
And then we'll write our names for the contact info.
That would be good. Because that was statics. For statics,
That's also
It is
really
very-
stressful.
yeah, so we have like 4 other finals.
I just texted my mom.
Us dynamics, we had like, we had a problem that was like, it was like a 3-page. We didn't have the ability, it was like, a problem that's like 1 page, and another page. And then you had the actually the SAC part, and the velocity was acceleration, and then like.
Is that there, Rutgers?
No, I did transfer from college.
Yeah.
I got all the questions for sessions, except for the 4, I think, where it was the elongation in the middle section. Is that not just using all the
Second
forces?
especially, well, I'm just sure spring, otherwise,
So
spring and
It's
spring and.
We should be sitting here next semester.
I'm not gonna go, I'm gonna, I paid 45 minutes each way, but also, this is gonna be cheaper than 10,000. Plus, I can still work and get tuition.
Oh, yeah, that's, yeah.
It's like 1,500 a year to get.
Oh,
Yeah.
You can think of it one way is to think
Yeah, I've got 4 plus of shit.
Well, like a restaurant slash bar.
Yeah.
As like a server.
Yeah,
And
same.
close, like, so you have closers,
Yeah.
right? You use that, you know, that's what I'm not trained to be a closer. That's the schedule. So I'm walking into my shift last night, I'm like, okay, hopefully I'm outside, so I can get to go home early, get my homework done, because I still have like 6 questions to do. And then we were like, we forgot to schedule the closer, so we closing the bar today. The bar is open until 1 a.m.
Yeah.
And so I stayed till 1, then got to leave at 2:30,
Yeah.
got back to my house at 3,
Dude,
just so I could start my work at 3. And I was sitting there, I'm just like, really? I don't, any
Out of all
I
the
refuse,
words
I
that.
refuse.
any day.
Well, there's somebody close, cause like, they close at 1.
Because all the other people working with new people, I've worked
Oh,
there for years, so
Wait,
it's
you had
like,
this bar was closed at 2?
Our bar closed at 1. Well, after 12, they like.
Oh, so it was like they
They-
stopped.
No, after, so the restaurant's up was at 11, and after 11, they like turn like the bar area into like a just dance and play a bunch of like shit. That's what I mean, I saw too.
we would have been out like 45 minutes earlier.
Yeah.
There would be table after last call, like they got their last drink,
Yeah.
and they sat there with no drinks. We're at 45 minutes talking about Dungeons and Dragons.
Are you serious?
Yeah.
Where do you work?
It's a Cleveland Tavern.
Oh, literally, I'm at Stagehouse. I don't know if you know class. It's like Stagehouse Tavern. It's like they have three.
Where is it?
They have one on the mountain. I don't know on the mountain side.